All right, let's try and solve this question, which has to do with the application of matrix determinant. Now, looking at the question, you can see that you're given a matrix A, which you can see the constituent of matrix A. And then you're told to find the non-negative value of x, which satisfies the equation A, the determinant of A equals to 0. Now, there are many points you need to take note of before solving this question. Number one, you need to understand that this question wants you to only give the non-negative value of x. So you would have to ignore every other value that doesn't fit into that prescription. Now, you told the equation you are given is that the determinant of A is 0. So obviously what you have to first do is to try and resolve the determinant of A being 0. So when you fix the A, this A here, this is it right here. So all you have to do is to fix in the value of A, as you can see. And what you would have to do is to then solve this equation. So you have to apply the determinant of a 3 by 3 matrix first, then equating whatever you get to 0. So there are two different methods. I'll be using the first method, which the way to solve the matrix determinant of a 3 by 3 matrix is to first add the plus sign on top of the first column, then the minus sign on the top of the second column, and then another plus sign on the top of the third column. Now what you do is to pick the plus sign with the first element, that's row 1, column 1. So what you do is to have plus x. That's the first thing to do. So this plus with this x is what I'm writing here. Then you will create the space for the determinant of a 2 by 2 matrix. So the concept is this. When you are dealing with plus x lies in row 1, column 1. So you can easily just trace this out, and what you do is to bring out the remaining value there, which is x1 1x. So this value x1 1x will be placed in this determinant braces. So that's the first step. So you go on, you can ignore the next. If you can do this very well and ensure you do it in such a way that you can easily follow through. So what you have to do next is to go on with the next one. This was plus x, so you do for minus 1 now. So you have minus 1 written, and then open up a new determinant braces. So this time you are dealing with minus 1. Minus 1 lies in column 2, row 1. So you cancel out row 1 and column 2. So what you will be left with will be 1 1 0 x. So you write that in here, 1 1 0 x. That's that about the second one. So you do the last one, which will be plus 0. As you can see, plus 0. We've done for plus x, we've done for minus 1, we'll be doing for plus 0. So plus 0, and then you also bring out the determinant braces. Now in this case, plus 0, this 0 lies on still row 1, but column 3. So you cancel out row 1 and you cancel out column 3. So you'll be left with 1x01. 1x01. So I really believe you should be able to follow through on what we have done. So this is the procedure for finding the determinant of a 3 by 3 matrix. So you go on to resolve this. So resolving this, obviously this is the determinant braces. So you have plus x. Then you then resolve the determinant of the new 2 by 2 matrix. So this is a 2 by 2 matrix inside here. So you find the determinant of this 2 by 2 matrix, which will obviously be the multiplication of the leading diagonal minus the multiplication of the other diagonal. That means we have x times x minus 1 times 1. That will be x times x will be x squared. So you have x squared minus 1 times 1, 1. So that's that. We have resolved the first one. So you go on to do for the next one. Minus 1. In here, we have a new 2 by 2 matrix also. 1 times x will be the minus 0 times 1 will be the determinant of this 2 by 2 matrix. So you do 1 times x, which is x minus 0 times 1. That's 0. That's going to be the determinant. And then the last one plus 0. Then you have 1 times 1 minus 0 times x. That will be 1 times 1, that will be 1, minus 0 times x, that's 0. So that's what we have right there. Now, we go on to keep solving. What we have here, we can easily expand this because this is x times x squared. That will be x cubed. X times minus 1, that will be minus x. Here we have x minus 0 will be x. So what you are left here with is x. That will be minus 1 times that x inside will be minus x. And then 0 times whatever you get, 1 minus 0 is 1. 0 times whatever you have here, which is 1, is still 0. So that will be plus 0, which you don't need to really care for that. Now, don't forget, this equation it was equated to 0. So we have our equals to 0 here, which we are supposed to add. And then we also have our equals to 0 here, which we're supposed to add. So we also will be adding that here equals to 0. So this is the new equation we have gotten. Don't forget the question said find a non-negative value of x, which satisfies the equation. Now, this is the equation we're initially given, but we've been able to resolve the determinant of a. We've gotten this, and then we are equating that to 0. So what we have to do next is to keep solving, which we will have x cubed minus 2x equals to 0. Now, obviously, this is an algebra. It has resulted to an algebra which we can easily solve by factorizing x. So if we factorize x out here, we would have x, then we have x squared minus 2 equals to 0. So obviously here, I believe we can deduce the result of what we have here. We will have x equals to 0 or x squared minus 2 equals to 0. Now, if x squared minus 2 equals to 0, obviously we know that x squared will be equals to 2. This 2 coming over here. And then we can decide to resolve this by taking the square root of both sides. That means we would have x squared, take the square root of this equals to 2, take the square root of this. Now, obviously, we can easily conclude that the square will cancel this other square. Then we'll be left with x equals to, now we'll be left with plus or minus root 2. Now, we have our x equals to 0, and then our x equals to plus or minus root 2. But don't forget, the question stated that you should find the non-negative value of x. This is not one of it. 0 is not a non-negative value. 0 is a neutral value because 0 is the basics on which you define positive and negative. So if you draw your number line, 0, everything below 0 is negative and everything above 0 is positive. So 0 is a neutral value, not a non-negative value. And right here, plus square root of 2 is the only non-negative value because minus square root of 2 will be a negative value. So therefore, our final answer will be x equals to root 2. We can write plus root 2 or just root 2. So this will be the final answer which we were told to to arrive at. I really hope it was really clear to you guys. Let me give you something to solve quickly. All right, so I really hope you could resolve this. The question is talking about a 3 by 3 matrix given below, and we're told to determine the value of a constant lambda so that a plus lambda I is singular. All right, guys, thank you guys for joining. Bye bye.